Howdy and good day, fellers. In algebra, we will be going over CO13, graphing and writing inequality statements, and then we'll be going into CO14, solving two-step inequalities. So we did a few of these together. I don't remember which ones, probably the first two. But since this is how your test is going to look, I'm just going to go over them all, and you can kind of get what you need to get. So burning at least 400 calories, your phrase there is at least. We talked about that means greater than or equal to. So C is greater than or equal to 400. You do need to write it the other way, which is 400 is less than or equal to C. Both of these inequalities have the same graph. Open circle at 400 going to the right. Okay. The next one, the most you can spend at the store is $20. So the money you can spend at the store is less than or equal to 20, or 20 is greater than or equal to the money you can spend. We talked about the limitations of this and kind of how this is not actually right, because technically, according to this graph, any number less than 20 would fit this situation. But we talked about negatives and things like that. But that would be the graph. You must be 18 or older to vote. So your age is greater than or equal to 18, or 18 is less than or equal to your age. Closed circle at 18. Graph going to the right. Needing fewer than 8 strokes. Fewer than would be the key phrase here. It refers to less than symbol. So my S's look like 5s. What did I use yesterday? Oh, V for victory. That's right. So victory is less than 8 strokes, or 8 is greater than V. The graph, open circle at 8, going to the left. Any just general questions thus far, or are things going well? Thumbs up. All right. Weighing less than 210 pounds. Weight is less than or equal to 210. 210 is greater than or equal to W, which is a closed circle going to the left. Yes? Oh, you're right. It's not less than or equal to. Sorry. I know, yeah, thank you for pointing that out. Open circle going to the left. Okay. And lastly, you can bring no more than $40 to the fair. So you can bring $40 or less. So the money is less than or equal to $40, or $40 is greater than or equal to the money that you can bring. Closed circle at 40 going to the left. Okay. Questions on those or other mistakes I made that need correcting? Okay. Next page, we kind of went into temperature. I told you that you'd be using each inequality symbol once. So kind of the one of the hints that you can use for greater than or equal to or less than or equal to is if the phrase has an or in it, right? Negative 25 degrees or colder, that's going to be one of those two symbols. But the temperature tomorrow will be colder than negative 3 degrees. So T is less than negative 3, or negative 3 is greater than T. Open circle at negative 3 going to the left. Our little number line thermometer there. The temperature a week from now will be warmer than negative 12 degrees. I sure hope so. T is greater than negative 12. Negative 12 is less than T. Negative 12, open circle going to the right. What? Okay. School's closed if the temperature is negative 25 degrees or colder. So the temperature is less than or equal to negative 25. Negative 25 is greater than or equal to the temperature. Negative 25 degrees, open circle going to the left. Any temperature on that side of negative 25, schools are closed. And finally, your parents will only let you go outside if the temperature is negative 10 degrees or warmer. So T is greater than or equal to negative 10, or negative 10 is less than or equal to T. Negative 10, closed circle going to the right. Yes, Gabby. I should have said closed circle. Yeah, because negative 25 or colder would be included. So if I said open, then I apologize for that. I'm on a roll today. If I just, oof. And then the bottom section, I gave you the graph. You needed to write the inequality statements that fit it. So you can use whatever variable that you want to. I'll use n. N is greater than 11, or 11. Yeah. Or 11 is less than n. Okay. We know it's greater than because it's got that open circle and it's going to the right, and that open circle is at 11. So that's why we picked that one. The next one, n is less than 4, or 4 is greater than n. N is greater than or equal to -4, or -4 is less than or equal to n. And last but not least, n is less than or equal to 6. 6 is greater than or equal to n. Anything to talk about? No. Okay. So onward to CO14. In CO14, like I said, we're going to start to solve two-step inequalities. And quite frankly, if you were to cross out this word inequalities and write equations instead, the process would be virtually the same. Okay? If you already know how to solve a two-step equation back from PO9 and a little bit in PO10, this is the same process with two exceptions. Okay? Does anyone remember from last year, perhaps, what you need to be thinking about when solving inequalities versus just regular old equations? Adam. Alex. My bad. Yeah, that whole flipping the sign deal, right? So number one thing, I call this the red flag of solving inequalities. Red flag, okay, is that when you multiply or divide by a negative, the inequality sign switches. Okay? When you multiply or divide by a negative, the inequality switches. And then the second thing, and we'll get to why this is and see examples of it in just a little bit, but how about the second thing, that extra step that when you get to the solution of an inequality that you don't have to do when you get to the solution of an equation? Daniel? I wouldn't say necessarily check it twice. Are you saying what works and what doesn't work type deal? No, that's a good idea, but not where I was going. So when you say pick a random number to, and Daniel said this, to kind of plug it in and check it, why can we really pick from a wide range of numbers? You know, because in an equation, you get the answer n equals 2 or n equals -10, and that's what you plug in and see if it works. Why in this case, you kind of have more freedom to pick something? Gabby?
N could be anything that was greater than L. So it could be, if L was 1, it could be 2 and above.
Right. So to show that range of values that your variable could be, you need to graph your solution. And we practiced doing the graphs on the homework for today, the open circle, the closed circle, which direction on the number line, all that sort of stuff. Okay. So the whole flipping of the inequality symbol and then graphing your solution. So a little bit of practice and a little bit of explanation on rule number 1 here. -n is less than 80. Can anyone tell me why we need to flip our inequality symbol? You know, the process for this, just like an equation, is opposite operations. What are we doing to n? We're multiplying by -8. So to undo that, we're going to divide by -8. which on the left side, they cancel out. Perfect, everything's good. And on the right side, we get a negative 10. But the inequality symbol that started out less than, because we did this step of dividing by negative 8, in our solution, it's going to be written as greater than. But why do we switch it? What about dividing by a negative number would require us to switch our inequality symbol? Quinn? Okay, so are you saying that if you checked it, then you'd see, okay, if you checked it, you'd see that if you left it less than, it's not going to work, right? But mathematically, why do we do it? Audrey,
You're like turning it the opposite would be, so you have to like opposite. You're like.
okay, I like what you said about the opposite of what you would, because what happens when we divide a positive by a negative? That positive 80, what? It became negative 10, right? We flipped sides of where we were with compared to 0. We went from the positive side of the number line to the negative side, right? And so mathematically what is going on here, and I'm going to draw it over here so don't feel like you have to write it down under all this other stuff, but take our solution, less than 80, okay? 0's here, 80's here. We're saying that negative 8n is less than 80. Negative 8n is going to be somewhere on the 0 side of positive 80, right? Where our solutions are going towards 0. Follow me so far? Less than 80, okay? When we get our solution, n is greater than negative 10, if we kept our symbol less than, are we still going towards 0 now? No. We flip our inequality symbol so that this relationship of going towards 0 stays the same. N being greater than negative 10, we're now, once again, going towards 0 with where our solutions can be. But it's the action of that sign of that 80 changing, jumping over the other side of the number line, the other side of 0, our inequality symbol must also flip so we keep that towards 0 relationship. Does that make sense? Well, don't just say that. I mean, does it really? I mean, okay. Well, I tried. Okay. So the next one here, negative 7n is less than or equal to 35. Our one step to solve this is divide by negative 7 using opposite operations. Do we need to flip our sign? Yes, we do, because we're dividing by that negative 7. Less than or equal to becomes greater than or equal to, and we get negative 5. I didn't graph our last solution, but I should have. It's a closed circle at negative 5 going to the right. And Daniel you mentioned checking it twice. Are you? I'm not going to require you to do it. What I'm asking is, did you mean that you would pick one number that works, make sure it works, and then pick one number that isn't supposed to work and make sure it doesn't work? Oh, great, gotcha. And so if it was just less than, then you'd only check it once. No?
I don't know, but
Elise?
you check it first by changing the inequality sign to an equal sign to make sure that the number you got is right, and then you would plug in like a number that works in your equation to see if the equation works.
Sure. And so if it didn't have the or equal to, would you only just then check it the one time? Or would you still check it but know that it's just not the or equal to part?
No, it's not showing like that it's equal to, it's just showing that like for this one.
Oh, gotcha. Okay. Yeah, I'm not going to require that level of checking. Obviously, I guess I would recommend it, but I'm not going to require it. Okay. N divided by 3 is greater than or equal to negative 6. Our one step to solve this, since we're dividing n by 3, we're going to be multiplying both sides by 3? Are we going to be flipping our inequality symbol? Julia? You do need to graph it. And this is the graph of an inequality. I didn't do it on the first one. Should have. Open circle, -10, going right by you. Okay. Sorry? Oh, you do not need a graph yet. Oh, I'm sorry. I guess I was looking at the directions for the homework. So, never mind. I need that to... Okay. But anyway, so when we multiply by 3 here to get n by itself, because of course multiplying by 3 will undo the action of dividing by 3. On that right side, our solution side, we get a -18. Do we need to flip our inequality symbol? Why not? Lucas? It's all about what you multiply or divide by, right? We do have a -6 there, but we're multiplying by +3. Okay? The sign of that solution side, -6, stayed negative. Okay? -18. So our inequality does not flip, and we do not need to graph yet. And I know that because I read directions. Yes, Bridget.
So we don't have to flip the sign if we don't multiply or divide by a negative number.
Correct.
That makes my life so much easier.
Good. Good. The last one, n divided by -4 is greater than -36. We're dividing n by -4. So to undo that, we're going to be multiplying by -4. On the left side, everything cancels out. N is by itself. On the right side, should I have switched that? Yes, because we are multiplying by a negative. -36 times -4 gives us +144. So the sign of that solution side changed. We went to the other side of the number line, and so yes, we do flip our symbol. Okay. All right. So down to the 2-step ones. Like we talked about, the process is very similar to an equation in the sense that you've got a coefficient, you've got a constant. You want to use opposite operations, move the constant over, multiply or divide by that coefficient, and then you're just going to graph your solution. So we'll start by subtracting 3. 7n is less than 14. Divide both sides by 7. And n is less than 2. No need to flip. We did not divide by a negative, but we do graph it. Open circle at 2, going left. Okay. How would you check? Audrey? Sure. Plug in a number less than 2 for n and see if it works. I always like to use 0. Whether or not 0 is part of the solution, I like to use it just because it's easy. In this case, 0 is part of our solution. So if I plug in 0, 7 times 0 is just 0. That's why it's easy, because that first part will just cancel out. And you're left with +3 is less than 17. True? Yes. Therefore, 0 works. Therefore, it's in the range, and that's good news for us. Okay. What Elise and Daniel and others were saying before about plugging in this 2, even though the 2 isn't going to make the inequality true, because 17 is not less than 17, this is a way to let you know that 2 is the right number you should have here as far as your solution number. Okay. It should get you to that 17. Take a look at some of the other ones on either this page or the next one. Any others you want to talk about? The ones on the next page, same 2-step stuff, but some of them look a little bit different. Any that you'd like to discuss? Bridget?
The first one on second page.
N divided by negative 2 plus 5 is less than or equal to negative 3. Okay, so we've got our term with the variable, right? Negative 2. Then we've got our constant. We're going to start with that constant. Subtract 5 because that undoes adding 5. Okay, so we've got n divided by negative 2 is less than or equal to negative 8. Negative 3 minus 5 being negative 8. Now, to undo dividing by negative 2, we're going to have to multiply by negative 2, which should send alarm bells and whistles and horns and sirens and all that sort of stuff going off in your mind because we are multiplying by negative 2, which means we need to flip our sign. Okay? So less than or equal to becomes greater than or equal to, and negative 8 times negative 2 gives us a positive 16. Because that sign changed, we have to flip our inequality symbol. Okay? And again, what? Right. Yep. And if you think about, again, the mathematical reason why, less than or equal to negative 3, if you think where negative 3 is on the number line, are we going towards 0 or away from 0 if we're going less than or equal to negative 3? Towards 0 or away from 0? Away from 0, right? Negative 3 on the number line, here, 0 is here, less than negative 3 is going away from 0. So we have to make sure our solution has that same relationship. N is greater than or equal to 16. 16 going greater than or equal to 16 is, again, going away from 0, right? If we didn't flip our inequality symbol, then we'd be going towards 0 from 16, which is not the relationship that we want. We want to be going away from 0. So when we jump sides on that number line, we have to flip our inequality symbol to keep that mathematical relationship the same. Okay? Another one on this page that you'd like to do before we get to the word problems down at the bottom. The last one. Why not? 14 minus n divided by 7 is greater than 11. This one, it's not me trolling you, right? But the constant and our variable term are switched. Usually that variable term is written first. This one is also, a couple others are switched. That one, second one too. But you always start with your constant, regardless of where it is. So the 14 being our constant, the opposite of a positive 14 is a negative 14. This is a good one to pick because two things here that I want to talk about. The first one, on our solution side, that 11 minus 14, starting with positive 11 and then subtracting 14 to get negative 3, would we flip our inequality symbol? No, never with addition or subtraction. It's only with that multiplication or division. Okay? So now we've got negative n over 7. What's our next step? Gabby? Multiply by negative 7. So we end up having to flip our inequality symbol anyway, but not in that first step. It happens now in step 2. Okay? N is less than positive 21. Okay? All right, good. Other questions? Okay, the word problems. Some real life application of inequalities. You and 3 friends decide to go in on a 15-book series. The 4 of you can spend a total no more than $212, and plan on dividing the cost evenly. Use a graph to describe the cost per book that the 4 of you can afford. This is kind of a multi-step, not with parentheses and combining like terms necessarily, but it's we'll call it 2. But so basically, if the 4 of you are splitting the total cost of these 15 books, and the maximum amount you can spend is $212. What is the cost per book that you can afford? Okay. A blank CD can hold 70 minutes of music. So far, you have burned 25. Do people still burn CDs? Is that a thing? Do you even know what I'm talking about with burning a CD? Some. So before your phone could hold everything in your life that you ever need, if there was music that you wanted to put onto a CD, you'd download it to your computer, legally or illegally, and then you'd put it on a CD that you could play, in your car or whatever. So burning music onto a CD would refer to, putting music onto a blank CD. Okay. So of the 70 minutes that are available, so far you have filled 25 minutes of music. You estimate that each song lasts 4 minutes. Use a graph to describe the possible numbers of additional songs that you can put on the CD. So 70 total. You've already used 25 of it. If each song is 4 minutes long, how many more can you put on? And finally, you spend $56 on supplies to make wooden ornaments and plan to sell the ornaments for $8.50 each. Use a graph to describe the possible numbers of ornaments that you can sell to make a profit, right? Profit would be more money than you put in. If you spend $56 on supplies and whatever else, but you only sell one ornament, you did not make yourself $8.50. Okay, you lost $45.50 or $47.50. Right? Because all the money that you put into it first. So I'm looking for the possible numbers of ornaments you can sell to make that profit. Make that profit. Any questions on this? Julia? I would like you to do the first and third ones on your own. So we'll talk about the second one. But basically, a blank CD can hold 70 minutes of music, meaning that the amount of music that can be on the CD has to be less than or equal to 70, right? You can't go beyond that, okay? Now, if each song lasts 4 minutes, we've talked about that word each before. What does that word each kind of represent? We also use the words per or every in the same conversation. 4 minutes for each song, 4 minutes per song. Audrey? Multiplication, because that's our coefficient, right? So I'll use M for music because my S's look like 5s, but 4 minutes per song, okay? If we put one song on there, that's 4 minutes of time. We put 2 songs on there, 4 times 2 is 8 minutes of time. 3 songs, 4 times 3 is 12 minutes of time, right? And then where does that 25 come in? That's what we've already put on the CD, so that represents our constants. And are we adding 25 to this or subtracting 25? 4 minutes per song plus the 25 minutes we've already put on has to be less than or equal to 70. So our first step here to solve this would be to subtract 25, meaning that we've got 4 minutes per song, and that's got to be less than or equal to 45 minutes of music, because that's how much time is left. Okay. This one is more similar to the second one than the first one is. The first one, I don't really know if you have a constant. I just think it's like a 2-step thing. So the directions don't say to write an inequality. The directions say use a graph. So you wouldn't necessarily have to write the inequality to get the answer here, but you can represent your answer with a graph, and that's what I'm ultimately looking for, if that helps. You're welcome. Anything else? Okay. Homework for tomorrow is to finish CO14. What's that? I don't know, because I kind of like to keep the 2 8th grade algebra classes together, and with tomorrow's 8C their Halloween class, I don't know what I'm going to do with you folks.
Wait, they have a party during.
It's just the last period of the day. So you'll miss your 7th period class tomorrow too. Yeah. So I don't know what I'm going to do, but check this in tomorrow. So this will be due tomorrow. Could. I feel like most I don't know. We'll cross that bridge when it comes. In the meantime, though, that is how you math.